Let us discuss the average case complexity of Quicksort. We have seen the best case complexity of Quicksort and worst case complexity of Quicksort. The best case analysis was we will pick the pivot element such that the pivot element will divide the array into exactly two halves. So n by 2 elements on the left of pivot element and n by 2 elements at the right of pivot element. We have placed the pivot element in the right place. Okay, this was the best case analysis, and we will get n log n is the time complexity. And in the worst case analysis, the pivot element will be the biggest element or the smallest element in the array. If the pivot element is the smallest element, all the remaining elements, that is remaining n minus 1 elements, will be gathered on the right subtree, that is all elements are greater than the pivot element. Okay, and if it is continued, you will get a tree like this. Okay, and finally it will reach 1 and you will get a complexity big of n square. That was the worst case analysis. And now let us discuss the average case. In an average case, the array will be divided into 3 to 1 or 9 to 1 or something like that. Okay. If it is divided into 3 to 1 in this proportion, it will be like this: total elements based on the selection of the pivot element. 3 by 4 of this elements on one branch, and the remaining elements, that is 1 by 4th of n elements on the other branch. 3 by 4 plus 1 by 4 is equal to 1, 1 into n equal to 3 by 4 n plus 1 by 4 n equal to n. 3 by 4 n plus 1 by 4 n equal to 1. Sorry, 1 into n. Okay. So, also coming to the next level, this will be divided into the total elements on this node is, the problem size on this node is 3 by 4 n. It will be again divided into 3 by 4 for the problem size 3 by 4 n, and on this side it is 1 by 4th of 3 by 4. This way it will be divided again. Here 3 by 4th of 1 by 4 of this element this side, and 1 by 4th of 1 by 4 on this side. Okay. So 3 by 4 n and 1 by 4 n, and the number of elements on this branch is greater than number of elements on this branch, and you know finally the problem size will become 1. The array will be the size of the array will be reduced, and finally it will become an array with 1 element. Okay, so this branch will come to an end very fast because number of elements is less compared to this branch. So this is the biggest branch. Okay. In the next level it will be 3 by 4th of this problem size, that is 3 by 4th of 3n by 4, and 1 by 4th of 3n by 4, Okay, so it is 9n by 16. This is 3n by 16. Coming to the next level, 3 by 4th of 9n by 16 this side, and 1 by 4th of 9n by 16 this side. So it will be 27n divided by 64, and this branch 9n by 64. So 3 times of this 9n by 64 into 3. You will be getting 27n by 64. 3 times. Number of elements will be 3 times more on this node. Okay. In considering these two nodes, number of elements on this node is 3 times than number of elements on this node. So this will be the biggest branch. Okay, let us number this. This will be level 0. This will be level 1. This will be level 2. This will be level 3. Then continue in this level K. We have to generalize the problem size. 2 here comes 9 by 16, 3 comes 27 by 64. So I can say in general at level equal to K, I can say, so 9 is 3 raised to 2, 16 is 4 raised to 2. So 3 raised to K by 4 raised to K into N. This will be the level K. It will be at level 3. It will be 3 raised to 3 by 4 raised to 3. When level is equal to 2, it will be 3 raised to 2, 4 raised to 2. So at level K, it will be 3 raised to K divided by 4 raised to K into N. Okay. Then at level I, it will be 3 raised to I by 4 raised to I, or I can say 3 by 4 raised to I into N. Okay, or let us write say 3 raised to I divided by 4 raised to I into N at level I. If I is the last level, we know the problem size is 1. That is 3 raised to I divided by 4 raised to I into N is equal to 1. What is I? What is I? For finding this I, we can write 3 raised to I into N is equal to 4 raised to I, and N equal to 4 raised to I divided by 3 raised to I is equal to 4 by 3 whole to the power I, and we can write I is equal to log n to the base 4 by 3. We can write I is equal to log n to the base 4 by 3. The next, how many levels? we know I is the last level and I is equal to log n. Level start from 0, 0, 1, 2, 3 up to log n. We have log n plus 1 levels. We know the cost at each level is Cn, because the cost of the cost of partition. Okay, it has to do partition. The cost of partition is Cn. Okay, let us check it again. Cost of this is Cn. Cn. Cost of this is C into problem size, that is 3 by 4 n. Cost of this is C into 1 by 4 n. So total cost at this level is C into 3 by 4 n plus C into 1 by 4 n. So it is C into 3 by 4 n plus n by 4 is equal to C into 4 by 4 is equal to 4 by 4 n is equal to Cn. So cost at every level is Cn. So what is the total cost? Total cost Tn equal to Cn into log n plus 1. I can write it is big O n log n. This is the convexity of average case.